Excellent. Welcome, everybody. This is Ask a Neighbor presentation. I'm Linda Gray with the Norwich Energy Committee, and we are lucky enough to have our colleagues from the Thetford Energy Committee who have organized a presentation. So three of them will be describing the work that each of them has done in their homes and what they did and how it worked for them and what they learned from it. And so I am now going to turn over the presentation to Erica Coe with the Thetford Energy Committee, and she will get the whole thing started. Thank you, Erica.
Thanks, Linda. I will go ahead and share my screen now and bring up our presentation. Let me see if I can resize it to something that looks good. Does that look okay on your screen?
Looks great.
Great. Great. And so this is a presentation about the various electrification and weatherization updates that we, your neighbors, have done in our own homes. And so we just wanted to provide some feedback, pros and cons, real costs, all those things that you might want to ask a neighbor instead of an installer or manufacturer. So tonight we're going to give a little introduction about who we each are and what we invested in and the things we learned. So these are us. I'm Erica Coe. I'm a member of the Thetford Energy Committee, and I'm also a local architect and very interested in green building. And I will pass it on to Klaus.
Good evening. My name is Klaus Keller. I'm a committee member in Thetford. I'm a member of the Thetford Energy Committee, and I work at Dartmouth. And
And what do you do there, Klaus?
yeah, I'm an engineering professor, so I work on energy systems but not on a household scale so far. Hi.
Okay. And I'm Pi Smith. I live in Thetford. I'm also an architect, and I'm also interested in green building. And have been, chipping away at making small changes to my house for the last 10 or 12 years.
Great. And then we did want to spend a little bit of time on the next slide, which is what did we invest in? And so this is kind of our big list of the broad topics that we have been working on in our own homes. And so we were just hoping to take a minute now to have all of the people who are joining us today just give a very brief introduction, maybe your name and where you live, and perhaps you could give us an idea of what you're most interested in learning about tonight or asking us about, whether it's on this list or not. But if it's on this list, we would love to prioritize talking about it for you. So if Linda wants to just go around and call out who she sees in the group, then if you guys are willing, it'd be great to hear from you. If not, we'll take your silence as silence and move on. So
Yeah, I'm just going to look through the list of participants that I see. So Jason Kelly is first.
Can you hear me?
Yep.
Yes.
Okay. I have something that's not quite on the list. I'm curious as to whether there's anybody setting up a community solar project, group project in the Upper Valley in the near future.
Thank you. We'll go on next. I see Irene. If you don't wish to unmute and say anything, we can go on. Next, I see Michael Pearson. Okay, go on. And then Todd Minsk.
Hi, I live in Hanover. I just in the process of buying a condominium which has a induction stove. I never used one before, so I was hoping to find somebody who could give me tips on how to make one work. I don't know. It's probably simple enough, but just like to see how it would affect my style of cooking.
That's great.
Great.
Thank you. Okay, so, and let's turn it back, Erica. Proceed. Thank you.
Great. So this is hopefully everybody's had a chance to just scan through our big list. And if something occurs to you as we're presenting, please feel free to either raise your hand or just speak up and ask us a question as we're going. We're happy to chat about anything. I might let Linda actually field the community solar question because I tend to put things in a sadder light than she does. So if you want to just
If you, yeah, to
address
just
that one now.
cover that, yes. So there is change in legislation. So new community solar arrays are no longer being permitted. So if you hope to be part of a community solar project, what you have to aim to do is contact an existing one and potentially buy a share there. In the situation of somebody who's currently a member moving out of the area, selling for some reason. So that would be the approach to take, because there are going to be no more new ones unless there is some future change in legislation. I would say that community solar, prior to the change in legislation that ended them, there had not been many projects being developed because the financial viability of them was more difficult, and so that's kind of behind why the policy was changed. So there are so in Thetford, for example, there were some relatively new community solar. I know there's several arrays in Norwich as well. So Norwich Solar Technologies is one developer of some local projects. And so I would say a way to proceed would be to get in touch with them. And I will be able to put in the chat a contact there at Norwich Solar that you could contact them to say, hey, I'm interested in some community solar. Can you keep me on your list if you have somebody who is leaving one of your community groups? So I'll
Thank
put that
you.
in the chat.
Great, thank you, Linda. So continuing on, the way that we organize this presentation, just to make it a little bit more personal and interesting, is that we're just going to review each of our homes and give you a sense of what we worked on. And it's a little bit interesting too, because we all kind of have quite different homes from one another and built at different times. And so we were all kind of dealing with different challenges and advantages. So it's interesting to see how things have played out across our different homes. So my home, we built ourselves in 2018. We have about 1,900 square feet of conditioned space. We were really interested in trying to create a good envelope. So we did a pretty good insulation and air sealing package, meeting the residential energy code back in 2016, which was the one that was in effect at the time. At that time, electrification was not as far along as it is now. So we have a efficient condensing propane boiler with water that also heats our water. And we have a small wood backup stove, and we had a gas range at that time. Since then, we started out by joining a community solar tracker field, one of, I think, the two SolaFlect community fields that they had. Sadly, they're no longer doing that, but we have been a part of that since 2016. And then we installed a ductless heat pump, so a mini split that, the one of those wall units that just goes on the wall with an outdoor unit in 2018 to provide heat and cooling on our first floor. Our first floor is very open plan, so it does a good job actually of being able to heat and cool the space. And we use it, I think it's sized to provide about 90% of our heating load. So it does a great job for us, replacing a lot of our propane usage. In 2022, we leased and then purchased our first EV, so an electric vehicle, and that is the Volkswagen ID4, which we purchased at the time because it was the only car with all-wheel drive that was like in the 40,000 and under range. And our driveway is terrible, and so that was the critical factor for us in deciding. And then in 2022, we replaced our gas range with induction, which we were anxious about because we do love to cook, but we've found that it's been wonderful and it's been a really smooth transition. So happy to talk more about that. 23, we installed a ducted heat pump and ERV to serve our second floor. So for our second floor spaces, which are more divided up because we have a couple bedrooms and a bathroom up there, we actually put the heat pump unit in the attic above, and then ducts come off of the unit and feed down into ceiling registers to do supplies and returns to go back to that unit. And then there's a fresh air system that's attached to that, which takes air from the second floor of our house out the back and brings it into the air handling unit. And then the return air comes in, exhausts out that way as well. So that was a big ticket item for us, but we have again been able to replace a lot of our propane usage by doing that, and avoided having to try and sleep in the concrete floor of our basement on those terrible days in the summer when we could not be on the second floor. 2023, we also joined Green Mountain Power's home energy battery program. So this is the program where you lease from them. So we don't own our batteries, but we paid a flat fee, which was either $5,500 or $55 a month for 10 years to, lease their batteries. So there are 2 batteries in my home for a total of 27 kilowatt hours. And that has also been a great experience. And then we also purchased our first electric lawnmower and strimmer in 23. So that was a big electrification year for us. Here are some of the costs. Admittedly, both large, but also mitigated in part by various rebates, some of which still exist, some of which do not anymore. But I think something that Pi has particularly tried to underline is that, this isn't an all or nothing proposition. We're all just chipping away and trying to make things better a little bit at a time. And we think that that is a really positive and important way that most people can make progress. So if you have any questions about any of these costs, I'd be happy to talk to you about them in more detail. Otherwise, I think we're going to move on to Klaus's house.
Thank you. Next slide, please.
Oh, I'm sorry.
Oh,
I see
yeah.
Jason raising his hand.
I have your ductless heat pumps. That only cost $3,200 for
Yeah,
that.
those were the days, 2018, before
Okay.
things turned to terrible. Yes, but yes, at that time, I thought it was actually expensive because I was like, this is just one unit, and why is it this expensive? But yes, we also have we have a more robust envelope, I would say. So we have better insulation and air sealing than a lot of houses. And so if you have somebody who's doing a proper energy calculation to size your equipment, I think that our unit might be smaller than what a more typical Vermont house would need for the same amount of space. On to Klaus's house.
Yes, so this is a house of I co-owned this with Irene. The house was built in 2003. It's pretty well insulated, but maybe not as nice as Erica's house. When we bought it, it had an oil heat system, an oil-fueled water heater, a small wood backup stove, an electric stove, and I had a huge backup generator. This was what we had. And we did a few changes at the very beginning, electric mower, trimmer, and snowblower, which were the first foray into electrification. And we liked it a lot. Then we added two ductless heat pumps, one in the main and one in the little place over the garage where I'm sitting right now. We then added a heat pump water heater. In 2024, we added a 10 kilowatt hour ground mounted solar array, which you see in the forefront to the right. And then we had in 2025 induction stove with two ovens. Next slide, please. You can see that the costs have escalated from Erica's house. So the heat pumps for two was 14K after rebate. The heat pump water heater was around 5K. So the total cost is 16K. The solar array was 26K. Induction stove with two ovens, which is a slightly bigger model, is 4.5. And then the trimmer, the mower, and the snowblower was smaller, but the biggest investment being the snowblower. We'll talk more about the cost benefit and payback period when we go through each installation. Little foreshadowing for the solar array. That actually is an example of it works really well and it pays back pretty fast. Next slide, please. I think this is Pi.
Okay, so I have an old farmhouse, so 1840, 1850, something like that. So I started with very minimal insulation, old windows, oil-fired hot air heating system, and then propane for my range, hot water heater and dryer. And I also had an old stone basement, which had a lot of moisture coming into it. So my early steps with the house were mostly focused on improving insulation and weatherization, and in particular, adding insulation and water, dealing with the water mitigation in my basement, which really helped my life in the house a lot. But and incrementally also meant that I was using a little bit less fuel to heat the house. So I started with those things back around the in the year 2000 or so. And then incrementally joined the Thetford Stratford Community Solar Array was my first foray into solar. Again, it was a relatively small way to start, something that I could afford and that I felt would make a difference. It didn't involve anything at my house. It just involved credits on my electrical bills. Then when the Thetford Community Solar project was undertaken, which is actually right around the corner from my house, I also purchased shares in that program and transferred my Thetford Stratford shares over to this Thetford Community Solar Array. So that held me for a little while, but then I moved on to installing a ducted heat pump for my second floor, which was driven primarily by the need for air conditioning rather than heat, given that it's the second floor. But what I've found with that is if I have the house really buttoned up in the summer, either the drying setting or the cool setting can actually, my whole house is comfortable if I just run this ducted heat pump on the second floor. And just, I think Erica explained this a little. Her house, the ducted heat pump meant that I have one piece of outdoor equipment, but then my air handler is in an attic space, and then ducts run to the bedrooms to supply the air. So I don't have one of those big white things on the wall. All I see is grills. So I moved from that to installing the SolarFlex solar tracker in 2023, which was very exciting to finally get solar on my property. And then most recently, at the end of this past year, I upgraded my electrical service because, again, old farmhouse, I think I had 150 amp service. And it was clear that if I wanted to ever have an EV or go to more electric appliances or go to all heat pumps for my heating system, I would never be able to do that with my current electrical service. So I upgraded to 400 amps and at the same time installed a battery backup. Um, and that has been great because when the power goes out, I don't lose my power anymore. Granted, it would only last for a certain amount of time, uh, which, so that's something I'm learning about how much electricity I'm using at any given time. But that's been a nice change. And then finally, I installed an induction range and a heat pump dryer. So that's as far as I've gotten right now. And again, it was all very incremental um, as I needed to replace things or as my I had enough resources to tackle one thing at a time. So, and then the next slide I think is just my costs. Um, and one thing I guess to say about the battery storage is that was quite expensive. As you can see, that's down the second to the last item. But there is a substantial rebate through Efficiency Vermont's Bring Your Own Device program that offsets quite a bit of the cost of the battery.
So to clarify, Pi owns her batteries and is participating in a GMP program for people who own their batteries. And I am leasing batteries and participating in a different GMP program, which, yeah, I don't own them, but the upfront cost was less.
Right.
I also wanted to make one other comment about the electrical service upgrade, just because I haven't gotten to deep dive into this, but since our last presentation, the steering committee for our shared energy coordinator, for those of you who don't know, there are 6 or 7 towns in the Upper Valley who share an energy coordinator. Norwich and Thetford are 2 of those towns. And we communicate about a variety of topics, and one that Linda has been pointing out to us, and that one of our other members, Matt Christie, does a lot of work with, is dealing with the issue of electrical service, since many of the older homes in our community have 100 amps or sometimes even less. And there's really great information now about how you can improve and electrify your home without doing a service upgrade. Because service upgrade, as you know, is quite costly. In Pi, you paid 11,500 minus the 30% tax credit that was applicable at the time, which is no longer, I think, in place. But I can share this article in the chat that Linda, I believe, sent around. And we are trying to organize another presentation by Matt Christie, and it has to do sort of with smart panels as well as other implements to manage electrical loads to make it so that the entire service upgrade is unnecessary. And so that seems really, really promising. And so I would say if anybody's interested in that, please give us your contact and we'll be sure to let you know about his presentation on that, because he's been doing a lot of research on actual projects and tracking that data in New York. So the things we learned. And so now we're going to go kind of slide by slide about all of those different topics that we introduced on our first big list. And feel free really to jump in if you guys have questions on any of this. And we will be sure to touch on, please also ask us more questions about induction, because all 3 of us have made the switch. So we can all give you, and I bet we all have different induction ranges. So we can give you lots of thoughts on that topic. But Pi, did you want to say anything further about
Yeah,
weatherization?
this is an example of what this is my basement of completely insulating the old stone walls, which was helped a lot with draft and temperature, but also reduced the amount of water or channeled the amount of water that was coming in through my old stone foundation. Um, and as a part of this too, again, old house, there's certain things that I'm just working with what I have, but I also run dehumidifiers in my basement all the time, basically, to help with the moisture issues, which both, is much better for my house. It's better for indoor air quality and health. And it's more comfortable because it's drier. So that is just an example of, small moves that can make a big difference.
I always like to plug the energy code whenever I get the chance. A lot of people don't know that we have a mandatory energy code in the state of Vermont. Some of you might be in New Hampshire, where that is, it's a different story. But I think that, it's if you ever plan to do any work, it's a great thing to ask your contractor about or whoever you're working with, just to see if they're familiar about it, because oftentimes some of these upfront costs are not that high. Doing a little bit more cost-effective insulation can pay off basically immediately. So it's definitely something worth getting into if you are pursuing any work. If anybody really wants to get nitty-gritty about it, these are in red, the tested or insulation values that I placed in different parts of my house, as well as our blower door test rating and, our window U values, et cetera, et cetera. So it's a little bit maybe more than we want to get into, but as Pi was noting, sort of weatherization and good envelopes are really the best starting point for reducing your costs as you continue on the electrification path. Klaus, did you want to talk a little bit about your fixed solar array, and then Pi, you could talk a little bit about your tracker? Klaus, you're still muted.
You would think I never did a Zoom call. Sorry. Thank you. Yes. So on the picture on the right, you see the solar array, which pretty recently installed, and we're very happy with it. It's easy to get installed by professionals, and it works like a tractor. You just forget it; it's just there. With the tax credit, we have a very fast payback, and so the calculations actually were borne out. We get actually a slightly higher performance than what we paid for, which is nice. Payback period, if tax credit is less than 10 years, which is nice. You can finance it. You get an immediate reduction in utility costs, and then once it's paid back, it's basically free electricity, which is nice. And of course, it also has a reduction in greenhouse gas emissions. The other part is that it is increased power reliability, and it's covered by the home insurance because it's attached to your house. And so the panels are covered by the warranty by the person who installed it or the firm. And if a tree falls over, it's actually covered by the home insurance, which is very nice. You get a little app, and you can basically, wherever you are on the internet, see how much has been produced, what's the net thing, which is cool. It increases the home value, and you have much lower bills, and they're stable because you're less vulnerable to it. So we right now have accumulated a benefit that we pay basically the connection fee, and then the other thing is basically free because we have a slightly over dimensioned in order to have space for an EV. There are, of course, a few cons. It requires an upfront investment or financing. And you have to purchase the panels, the trenching, and the electrician time. And also, it requires basic control with good solar access. And if it's close to your house, it's much cheaper. if you go beyond a certain distance, it's much more expensive in terms of trenching. We have chosen to go with the fixed design because we like to have things to be stable and easy and very few things that can break. But we can do this because we have more space, plus the panels have now decreased in price. We priced out the tracker and the fixed design, and we decided the fixed design. Pi has used the tracker, which is more elegant, and Pi can comment on that. Pi, over to you.
Yeah, so the picture on the lower right, and I'm sure everybody has seen these around the Upper Valley, is a solar tracker. So it basically it follows the sun all day. So it's on a single post and it changes in its angles. So it's quite efficient in terms of getting the most it can out of the sun. And I had the combination of the distances from my house, the trees around my house. I didn't have roofs that were appropriate, so this ended up seeming like the best option for me. It did require a bunch of trenching. And you can see there's a tiny little thing behind the tracker. I'm all set up and trenched, wiring, etc., and the foundation for a second tracker to go in. This was this was an expensive item, and so I ended up financing it. This was through Solaflect, and they have a relationship with Mascoma Bank, so that was pretty seamless. So I have a 10-year financing on this on the tracker. It has a great app, so I can see what's happening. And just as Klaus mentioned, basically my electric bills are as small as they can be because I'm covering everything else except for the charges that you have to pay them each month, which is like $30. So it's been great so far.
I see hand up from Jason.
Yeah, can I ask, did they have to do a full distance trench for the second one, or were they able to, is it sort of a Y configuration?
One goes right to the next. So
Okay,
and that was why I did it together so that it could all be connected and the wiring in, and it just literally they could crane it in place and turn it on and it would be going. Um, Sadly, I didn't, this is where, planning ahead is good, and I didn't plan ahead well enough because I did a bunch more trenching for my new electrical service. So I've had a lot of trenching in the last 3 or 4 years at my house. Hopefully no more.
And Pi, I think you're the only one of us who has both at-home solar as well as battery backup. Do your solar panels feed your battery?
They do. They
And
feed my
so,
battery, and I
Nice.
can choose whether they are basically, I think I can choose whether the solar and it's different by the different time of day, whether it's going right to my house or whether it's going to the batteries. And one of the really nice things, and I think there's a slide later that shows the app for the batteries. Um, Basically, it's set up right now, so they're charged at something like 30%. Most of the time, you can see in the second, the picture with the second one with the house, one more over to the right. My battery was at 63% when I took that screenshot. But most of the time it's more like 30%. So it's keeping a little bit of reserve there, but the rest is just going to my usage in the house. But if there's a weather event predicted, and this will happen automatically, although I can also go into the app and set it myself, it will prioritize completely filling the battery and not putting anything, not putting the solar into my house or the grid. So that then if there's a weather event and the power goes down, I've maximized what I can with the battery.
And Pi, if there is still sunlight when the power goes down, your battery will continue to charge, correct?
Yes.
Yes, as it discharges into your
Yeah,
house.
so if there was a several day, power outage, then I might, be burning through power in the night, but it would be recharging again the next day.
Linda,
I just wanted to weigh in with a little anecdote because I have solar at home and I have the same power battery storage that Erica has, which is mine are owned by GMP, but in my house, and they're connected to the solar. And there was this example from, let's see, possibly now it's 3 years ago around Christmas. We had a
Yep.
very wet snowstorm. My power was out for 3 days. And so I was just very careful to do not to not use much. I switched off, I turned off my heat pumps, I wasn't charging my EV. So I was very, very careful with electric usage, but it lasted through the period of time. And I made a point to clear the snow off my solar panels because they're out in my field. And even though it was cloudy over that period of time, they did feed back in enough additional power over those 3 days to keep things going. And I could tell because right the last day before the grid power came back on, when I got up, I could turn on the radio and the lights, but then after a half an hour or so, they went off. Then I went out and went for a walk and stuff. When I came back, they were back on because there had been enough light that there was a little bit more power accumulated back in the batteries, and they could run lights and refrigerator and water pump and stuff like that. So, and I want to echo what Pi said, because GMP is indeed very, very careful to not drain the battery when they can tell that there's some event that could very well take down the grid.
thanks, Linda. Yeah, I think it's a good point to mention that even if you don't own your batteries and you're doing the lease program, you can have your solar feed the batteries and help sustain you during an outage. And, I think that those of us who are trying to get through a long outage, usually what we're mostly trying to keep going is like our water pump, right? And some heating if it's winter to prevent things from freezing. And I think that, if you reduce your loads to that, it can really last a long time.
Um, well, I have something more to say about batteries, but we will get to the battery page, I suppose.
Here it is, Pi.
Oh, there it is. Okay, sorry. So the other thing, the other thing is that when that you can choose how you set up your batteries and how it's intersecting with your power usage in the house and the way your electrical panels in your house are structured. So, for example, my battery is hooked up to one electrical panel in my house that has, most of my lights and the water pump, and it has my heat on it. It doesn't have any of the really big new energy hogs on it. It doesn't have the induction stove on it. If I got an EV, it wouldn't have that on it. And the heat pump is not on it. So basically, we've opted to say, we're not going to ever try to cover that stuff with the battery. We're just going to go for the sort of base loads that mean you can get through a long power outage in a sort of minimal way. Obviously, you could design that differently so that you had more batteries and your goal was to be able to just live your normal life off of the battery. So that's just a choice you make as you're thinking about how you want to set up your system.
Yeah, and I think that Pi's system is shown here. I believe yours is outdoors in an unconditioned
Yeah,
space, but
it's in part of my
undercover.
barn. Yeah.
Yes. And mine, the Tesla system, I really gave them a hard time. That's what you'll learn about us, the engineer and architect group. We give our installers a hard time and are here to teach you how to do that too. So I was like, I don't want this to take up any space. So these are two batteries. You can stack the Tesla batteries so they don't have to go side by side on the flat. They can sandwich together. And I was like, let's stick it under the stairs and just put it on the ground. And they're like, okay. And then this is the gateway for the battery. So these are the components that that they often are giving out with the GMP lease program. I think that besides the real benefit of having power, I think it's also great when, for those of us who work from home, sometimes we just have very short outages, as you guys, I'm sure, all experience. But even if it's 10 minutes or an hour, if I'm getting kicked off my meetings or, unable to continue working because my computer shut down, it can be very disruptive. And so it has been really nice that oftentimes I won't even notice that my power has gone off until I get a text from my Tesla app that says, hey, you're running on your battery now. So that immediate transition is quite nice, especially probably for those of you who have hauled your generators out of your garages and plugged it in and gone to get diesel and filled it up and, that whole thing. So Klaus has a nice, I think, automatic generator that turns on when his power goes off. But the other thing we do want to mention about this is that the batteries in the state of Vermont are providing a service to all of the ratepayers. We are improving our grid resilience, and also because at peak loads, they can draw power from our batteries to offset like those very high peaks of demand. That is more cost effective because those times are when we have to, as a state, pay the most for power. And so that impacts all of our rates. Jason?
I wonder if, as we transition to more newer electric vehicles that have a V2H option, whether batteries are going to become a thing of the past, home batteries.
Yeah, I think it's a great potential, and I think that it's a very exciting potential. I do wonder, I guess, there's the convenience factor of the home batteries that it just switches automatically, which you wouldn't have with a vehicle. Um, and then there's always then you can't drive your vehicle if you're using it to charge your home. But I do think that like for people who don't rely, I think that if I didn't work from home, the amount of outages I have, it's not like a huge deal. I could probably, if I had, a lightning truck and I could plug it into my house, that would be sufficient for, time to time situations. So I think that that is something that I'm hoping will come to fruition sooner rather than later.
And are you aware of any estimates? We unfortunately just upgraded our panel at our home, but I wished we'd thought ahead to V2H options because you have to have I think you have to have all the circuits for the utilities you want to use during a power outage, all arranged in a certain
Separated.
configuration. Have you seen any published estimates as to how much that costs and uh,
I have
through an
not.
electrician?
I'm not, though I don't know that. I know a lot of people do this, separate loads to put on their generators. So I don't think it's a huge cost item, but Linda, I don't know if you've had any experience with this.
Sorry, no, I don't have any extra info.
Okay.
Anything else on battery storage? All right, cool apps for everything. Solar, batteries, everything. Great. Heat pumps. We all have heat pumps. We've got ductless heat pumps. And then I just included a few photos of what you see with a ducted. I think Pi has similar grills and things. So I've got two grills in this room, and this is actually a ceiling supply, an outdoor unit, indoor unit. But yes, Klaus, do you want to jump in on heat pumps?
Yeah, I can. Um, so we got two heat pumps, small units, and we are really happy with them. There are a few advantages. One is it's a cost reduction compared to oil. Second, it's a reduction in greenhouse gas emissions. And the third, which is the big one, we didn't think about it initially, but cooling in the summer is actually a quite an increase in comfort in the house. And it's the dehumidification and the cooling together, which makes you sleep better and it's just more comfortable. So cooler summer is increasingly important. It can be a low pain installation when you use a good firm. We can talk more about this. It's easy to use, and it's just it just works, which is really cool. There are a few things you need to be careful with. One, of course, an upfront investment. Second, you should first weatherize before you do a heat pump because that's the cheap way to go. That's a it does heat a different way than other people are used to. So I like radiant heat, and then you have an airflow, and in some places, if it's not well done, getting used to. You have a slower change in temperature, and then of course there are some aesthetic issues that some people they don't like the big white boxes in their houses, and then Erica has a smart solution to that. Other people are more less bothered by that. I think the key issue here is the following, that this is not, and set it and forget it, or this is not a thing where it's easy to dimension it. This requires actually smart people to do a calculation. And if you just do the standard thing and you say, oh, this looks like an X solution, that seems to be difficult. So there are people who gotten heat pumps who are not happy with it. And I think one can trace this down to maybe less than careful people who dimension it. So I would talk to Efficiency Vermont or a mechanical engineer to actually do this carefully. Erica and Pi and I were maybe a little bit obsessive. Well, I am. And I talked a lot with the person who did this, and I want to see the calculations. This is maybe overkill, but it works well. And for all the cases that we have, it works well. But I know of people that were not that happy. So that's, I think, one thing we learned, that's not an easy thing because still a little bit difficult, and people need to know what they're doing. Erica, does this make sense to you?
Yeah, I think that this is something that we really want to highlight for people because it's very unfortunate when we hear about people who are not happy with their heat pumps. And the real truth is that designing the heat pump system, sizing them appropriately is something that most installers are not doing because that's not really their knowledge base. They're really well trained on the actual installation of the equipment, but not the sizing. So they rely on the place where they get their distributors to do that. However, most of them are just basing that on square footage. But you can imagine you could have, in a 100 square foot bedroom, but if your ceilings are, 12 feet high, it's certainly going to be a different amount of space than if they're 7 feet high, right? And then if it's a drafty, leaky, single paned farmhouse versus a super hermetically sealed passive house, they're also going to be extremely different. And so if someone's just looking at the square footage and just throwing a unit at you, there's a high chance that it might not be the right one. And so it is both bad to oversize equipment as well as to undersize equipment, both for heating and cooling, because they will not run as efficiently as they're supposed to, and so end up costing you a lot of money. And the other thing I really want to highlight for people is that, especially with older homes, there is a really big difference between cooling load and heating load. And so we're still in a climate where, if you think about it, all the days of the year that you want to have heat on in your house is enormously more than the days of the years that you really, really feel like you want air conditioning, right? And so the sizing of the equipment is it is relational to that. So if you just want cooling, which is fine, not offsetting your, greenhouse gases, but if you want that, there's a good chance that that equipment will not be suitable for heating, and vice versa. So I think that is the one big conversation you should have with your installer, as well as asking them, how they're going to size the equipment and then say, can you do a manual J calculation and give it to me for the equipment? And if they're like, no, then maybe you should ask around a little bit more.
The other part, sorry to jump in here again, is that we decided to have the heat pump to not be 110% of our load, but slightly smaller. And then we have a little wood stove, and we still have the old heating system there as a backup. And that gives you two advantages. One is the backup if power goes out. We can still have a wood stove, which is nice. Then it's less stress. And secondly, a slightly smaller unit which runs at high efficiency is better than a big unit which goes on and off all the time. And so those are things you learn when you talk to a few smart installers and smart people. And so I think that is the thing I learned the most, that uh, think before you build and buy, and thinking smart here actually works. There are many things which is just fire and forget, like an water boiler. That's a commodity, but this one is still requires thinking. Linda.
I just wanted to piggyback on that and also the incremental steps that Pi has been emphasizing, to say that I think it's very valuable for people, and particularly if you look at the perhaps the cost of switching over one's entire house to a heat pump heating system might be daunting, but if you instead concentrate on heating the places within your house, the several rooms where you hang out the most and need heating, that can switch over the majority of your heating to electricity, and thereby you can reduce your fossil fuel use with potentially a smaller bill. So you don't have to go whole hog and try to convert your whole house, especially if you've got, you know, an old farmhouse that is difficult to deal with. So consider that type of incrementalism within your house.
Absolutely. You'll see that none of us are an all electric house as of yet, but we are chipping away and have greatly reduced our fossil fuel use.
Then I can
Heat
take
pump
that.
water heaters. Go, Klaus.
So we had on the picture on the right, you see the old oil burner, and that also was the water heater, which was really awkward in the summer and slow and dirty. We just hated it. And we said, well, what about a heat and water heater? Because the old one was actually at the end, and if you go to heat pump, then it's weird. Um, and we really like it a lot. It's easy to install. You have an app if you want, or you can just set it and forget it. It reduces humidity because you see in the bottom here, there is a condenser, then it gets out, and it cools the space you're in. And so in the summer, so most people, we used to run a dehumidifier, actually 3 dehumidifiers in the basement. Now we don't run any because it just does it by the water heater. It's cooler and it's quiet. It just works. It's really nice. There may be a few cons, you have to have an investment, but actually I think it's getting very affordable. It requires a drain for the condensate, but to be honest, if you and water dehumidifier every morning you had to go down and empty the bucket, or when you travel, it's weird. This one, it just works. I have a little water alarm you see on the right, so if it ever fails, I get a little ding. That's really cheap stuff to automate. It Some people say your pipes burst because it freezes. No, that's never happened in our place. It just cools it down by maybe 5 degrees Celsius, or So it's to be honest, there is very little we want to go back here. That works just well. We're very happy with this. And that is something you don't need to think hard about it. You just get a normal dimension, and there's nothing really, no mess. Next.
Yeah, not tricky to size. I do think that if you happen to have only space in like a conditioned room or next to a conditioned room that you use a lot, obviously in the winter, if the heat pump's kind of taking heat from that room, that could be a cost issue for you. So that's really the only consideration, I would say. I feel like if I got a heat pump water heater, I could be almost down to zero on my propane, but can't
Yep.
quite afford that yet. But hopefully soon. I am excited to hear more about Pi's heat pump dryer.
Jason, you have your hand up.
Yeah, Klaus, could you say something about the payback time for the the heat pump hot water heater? Because we have a fairly new propane um, instant hot water heater, and I'm reluctant to take it out, even though it's on propane, because of the
Well,
payback time.
I have to admit, I obsessed about the payback time of the solar panel, and I did calculations myself and uncertain discount rates, stochastic derivation. I'm an engineer, um, and now it actually works. There, we didn't do it because it wasn't that expensive, and the benefit of having it is just so great that it just was worth it. So it wasn't that much more money, and it's so much more bang for the buck that we just says, well, it's worth it. So. And then also the investment for that is much smaller than for a solar panel. The solar panel is a big ticket item. This one is if you need to replace it anyway, and if you change it from the since we didn't run the oil heater, it was just an odd appendix that didn't really work anymore. So long story short, I didn't do a cost benefit analysis of that one.
Okay. How many gallons did you put in, and how many people are in your household?
I don't even know how many gallons there are. I trusted my installer on that one. We are typically 2 to 3 people. It just works. Send me an
Okay,
email. Send me an email, and I can give you the information.
thank you.
Yeah, I was going to just say that we put one in my sister's house too, and it was a bit costly. I was trying to see if I had that information on hand, but I don't have it on hand. But they needed to replace theirs anyway. So I'm also in the same situation as you, Jason, whereas, mine is working fine. So the cost seems, you know, a little bit much right now, but I think costs are coming down on that as well. So I think also, I think for Klaus, he has that added benefit where it's providing that dehumidification that's helpful in his basement. And so there's some of those other tangential benefits that can also make the cost worth it, I think.
It it also took a long time to get the hot water. So you do your dishes or you shower, and it takes the boiler has to start, and it goes on, and then the water is always hot. You never have cold water. So in terms of functionality, it just wasn't really as nice. This one, it just works. You have hot water, and it's very convenient.
Hmm.
Great.
Okay, on to dryers.
Yeah, how's it going, Pi?
Good. I've had my heat pump dryer since January now. Um, and it's working great. The really nice thing about it is that is that you don't have to vent the dryer to the outside. So you can put one of these things. I mean, you have to have water for the washer, and you have to have a drain and power, as you would expect, but you do not have to vent to the outside anymore. Um, so the downside is that it takes longer to dry. But I have not, I can plan so that that's not really a problem. And I think that would be a matter of the composition of your household and your laundry patterns. For somebody who was putting a dryer into a summer house where they're, leaving and doing many loads of towels and sheets, for example, probably wouldn't be a great fit if it's going to take a couple of hours to dry load of laundry. But it's been working great for me. And it's a heat pump system, but unlike the hot water heater, it is not draining the heat out of this is in a bathroom in my house. So that does not seem to have been an issue. Um, and basically, it's been really easy and smooth so far.
And Pi, it does not have a condensate drain.
It
Is that
does.
right?
No, it
It
has
does
a
have a condensate.
condensate. Yeah, and the condensate the drains into the washer drain line.
Okay. Okay, that makes sense. So you don't have to worry about it,
No,
where it's going. And then
right.
did you say, does it, for like a typical load, let's say with including some towels, it could take something like 2 hours to dry
It
or
could, yeah.
Hmm.
Yeah,
yeah.
it's got a sensor, so it's, what I've been finding is it's pretty smart about knowing when stuff is dry. Occasionally, I have to turn it on for a few more minutes, but that's been doing really well. Um, so yeah, so far so good. It also, the slower drying time, it doesn't get as hot, so it's
Mm,
also a little easier on your clothes.
Mm.
mm,
Oh,
mm. Definitely on my list. I mean, I hope everybody's cleaning out their dryer vents, but it's a terrible ha thing to have to do. I mean, I pretend I do it, but my husband does it, so whatever. But your dryer starts working less and less well, and then you have to like take apart the vent and try and clean it out, and then it's, is the vent gonna get covered with snow, et cetera, et cetera. So this is definitely high on my list too.
Yeah, and it's more efficient.
Mm,
Here it says,
right.
no, it's like 28% more efficient than either a gas or electric dryer. So,
Very,
um,
very
yeah.
cool. Okay, we finally got into induction ranges. And here is a photo of Klaus's with his cool two ovens on the left, and mine, pretty normal, on the right. And Klaus, you're excited about induction. You want to say some stuff?
Yeah, we can also have Irene, who's also on the call if she wants to speak up. But so we like it. What is amazing is it's amazingly fast. If you want to cook water, it's mind blowing. That's nice. There are no toxic fumes, which is really helpful for air quality, and it cools down so fast that it's kind of it's Klaus proof. That it's easy. So from that point of view, I think it's really nice. It is a new technology, so it requires a little bit more getting used to. So the surface can be more vulnerable. So it's if something falls on top of it, you really want to be careful with that. And if you have old pots, then it may not work. So basically, take a magnet, and if it sticks, it works. If it doesn't stick, it does not work. Some of them make slight buzzing noises, which takes getting used to, but compared to the fumes, that's actually something really minor. The first time you see, you say, "What the heck is that?" And you say, "Oh, okay." And you have to think in levels like digitized as opposed to, in the olden days, you just have the angle. The angle is a setting. So it takes a bit more. It's more electronic. You see, there's this ginormous keypad thing, which takes getting used to. So there's a little bit more thinking. Maybe I'm old-fashioned, but overall, we're very happy with it. It's quite nice, and on balance, it's a great investment, and it's really nice. Erica, what's your experience?
Yeah, I mean, I'm super happy with it. Also, I feel like people don't know, and I had not really understood how bad the toxic fumes you are getting with propane combustion inside your house are, but it is not like a small issue. It is a serious indoor air quality issue. Also, because the surface cools so fast, it's so much easier to clean because you don't get that burned on, overflowed starchy pasta water all over the place, etc. Uh, the only thing I think that does occasionally bother us is that unlike, the gas ranges where you can dial an infinite amount of sort of dialability in the flame height and heat, now you have numbers. And so, there's an occasional time where I want it to be 2.5, but it can only be 2 or 3. But I feel like that's a very, very minor thing to get used to. Cooked all kinds of stuff on this. I don't know, Todd, if you had any specific questions about yours that you wanted to run by us.
Well, I currently have where I'm moving away from is a uh, conventional electric stove
Hmm.
with coil burners, and I don't have any problems with it, mostly because I'm accustomed to using it. But um, I'm wondering if I should accidentally drop a piece of plastic onto the surface of the induction stove, is that going to catch fire the way a regular stove would?
Not at all. Not at all. It's really amazing, the safety. I mean, I can almost put my hand on it like 2 seconds
Yeah.
after it's been boiling a pot of water. It cools down that fast. And the surface, while people talk about its vulnerability, I have had no scratches. You know, I use cast iron on mine. I don't know if Klaus or Pi, you've had any issues with yours.
Not not really damages. It's just the fear that something falls from a meter down, and then you say, "Oh shoot!" So that's the concern. But in real thing, we had this before and it never really happened, so it's okay.
So
Yeah.
Okay, this is Irene, and I'm sorry I have had some technical difficulties. If I can just quickly chime in, I really like the induction oven because you turn it on, it's on, and if there is a magnetic pot on top of it, and whatever else you put on there, plastic or ceramics, it will not heat up anything because you need that a magnetic field, which is kind of a downside if you have a pot that is not magnetic, but it works incredibly well. Very quick on, very quick off if you want to have it off, as Erica said, and I love that.
Right. Good point, Irene. So yeah, Irena, sorry. Going back to Todd's point, yes, if you dropped plastic on it, it couldn't even, ignite because it would not have that magnetic connection to heat up. And that is also a great point because I also like to put a lot of stuff on my stovetop while I'm cooking. So it's almost like another surface because, I can put like my lid holder and then like a few dishes right on top of the range itself to start, like serving things up. It just because it's the whole rest of it is cool except for the little pad that the pot is on.
but
Linda.
the cookware itself would be heating up, correct?
Yes, but only when the pot's on it. So only the ring that the pot is on is warm, and then everything else, even right here, would be cool.
Okay. Well, I had to get entirely new cookware because what I'd been using before was copper bottom, and that won't work on induction. But I wasn't able to find any induction compatible cookware that had insulated handles, and that concerns me a little bit because I don't know how to keep putting on an oven mitten just to pick up a stove pot.
You can test your if a pot is good for induction stove by putting a magnet on it. If the magnet sticks, you can use it on an induction stove. If it doesn't, it doesn't. And they make also pots where the metal handles are of a different metal, and you can kind of insulate the heat conductivity, so you can actually touch the handles of a pot with boiling water without burning yourself.
Well, are you able to recommend any particular names? Because I could not find any with insulated handles.
Send us an email. You have the information, and then we can send you something back.
Okay,
Yeah,
who
we
can I
can-
write to, please?
Yeah,
Klaus, can you drop your email in the chat?
yeah, will do.
Linda.
I had a question about the stovetops.
Chris,
The
you're
size.
jumping ahead of the line. Okay. Chris is also on the
I
energy
know there
committee,
was a
so
line.
I can heckle him. Go ahead, Chris. Just get in here.
I have a single burner induction, and I've noticed that it doesn't heat anything outside of the size of the ring. So do all these stoves come with a 12-inch burner?
They all have different size burners, and I have found that I can put smaller pots on the larger burners with good success. I know that if it gets really tiny, it can not detect it, but I haven't had that problem yet. I have very large, I'd be surprised if you're using a larger saucepan than I am, and it seems fine. It has enough contact with the largest burner that it heats up just fine.
So what size is that burner? You know?
I don't know. I can measure mine and let you know, Chris.
10 or 11 inches. I mean, it works with a big saucepan.
Hmm.
Also,
Sorry, Jake. Oh,
Yeah.
go ahead, Tom.
How does the oven work? It's not induction, is it? Just the stovetop, right?
Right. The ovens are just electric.
Okay. Thank you.
And
Electric convective too.
And I do want to weigh in. I want to let people know if you want to test out using an induction burner, there is something like this, which is basically like an induction, not, I don't want to say hot plate, but yes, basically. So it's something that you can just buy for under $100. And so if you want to do that as a way of dipping your toe into induction cooking waters, that's a pretty easy way to do it.
I just checked, and my biggest burner is 11 inches in diameter, and I am able to put this saucepan on it, and it heats up just fine. This is about 13 and a half.
The bottom is 13 and a half?
Okay, the top is a Chris, you're killing me here. Okay, the
The
bottom is 12. Bottom is 12. What are
Okay.
you cooking that's bigger than this? If you go for the extremely fancy, incredibly expensive, super, super high-end ones, you can also get ones that have like really large, like for griddles and stuff. That will, yes, should you be excited about that? Okay, anything else on induction? Okay, we're getting into smaller and smaller things here. So we've got electric snow blowers. This is Klaus's slide because he's the only one of us who has this very cool electric snow blower.
Yes, so we moved here from Pennsylvania, and then we didn't have a snowblower. Then we say, holy smokes, it actually snows here quite a bit. We need a snowblower, and we of course thought, well, what about the standard thing, the gas powered? We soon found out that the electric snowblower is just a game changer. It is light, it starts, there's no maintenance, it's powerful, it is low noise, low air pollution. And if you have from the same brand, the batteries are swappable. It's really nice. And so you see, this is an example where there was this large snowstorm with lots of snow, and we have two batteries. It comes to snowblower. We have another piece. We have sort of a set of four batteries. And with the second set, we can have our entire driveway, even with wet and deep snow. So from that point of view, it is really nice. The reduction in weight and the low start time, it's just a click, and it's self-driven with light. It's nice, and I've seen other people with the engine-driven. It's a pain in the neck, and so anything that helps me to have less pain in the neck is a good thing, and it's actually pretty affordable, and it just works.
Klaus, did you clear this pass with one pass? This is a
Yes,
one.
yes,
And
yes.
that's
This is
probably like
it's
4 to 6 inches.
yes. You see on the right, this is the shovel is in there. That is it was uh
Mm,
25, 30 centimeters. Sorry, I'm metric. It's pretty deep. It
wow,
just goes through.
very cool.
yeah.
What's the
Electric.
brand? Oh, it's an Ego?
Yeah, it's an Ego.
Yeah.
Yeah, and we bought it at Fox, and yeah, it works.
Very cool. Electric lawn equipment, also really great. We've had great success with our lawnmower and our strimmer. I think that another thing I've really learned about is how incredibly toxic the small motor equipment is, especially
Yes.
two-stroke engines. They're not regulated like cars, so they actually create an enormously outsized amount of pollution that you are standing behind and inhaling as you're embarking on these activities. So both from a health as well as a pollution standpoint, for the environment, it's pretty bad. So these also, I think, have gotten really cost competitive, and so I feel like it's been an extremely easy transition to the electric lawnmower and trimmer. It is true that, it's nice to either have two batteries so that you have one charging, and then, because you can't do a big lawn or large area with just one.
Can I ask what battery, Klaus, you're using for your snow blower? Is it the 5 amp hour or the 2.5? Or
To be honest, I should know. I don't. It just works. It came with the blower.
It's probably the 5. It's probably the bigger one.
It's a
yeah,
bigger one, and
okay,
they work for light, because light snow is one battery set. If it's really deep and thick, I need a second set. But look, with a mower, we have the trimmer and we have the snowblower. So we have
yeah,
basically 5 pieces that came with, and that's more than enough than you need. And
Right, because
look, if you're yes, if you're a commercial enterprise and you want to do 5 hours a time, then you may not do something else. But after 2 hours, I also want to get a cup of tea and do something else at some point. So
right.
it works.
Yeah, so that's a good point too. The batteries are often the bigger part of the cost of these pieces of equipment. So it can be good to find a company that you like and stick with it, because then the batteries will be swappable between the tools. Electric vehicles. Here's a weird picture of my ID4. I didn't have a great place to put a charger, so we just stuck it on the pedestal, at a random corner of our driveway on a slope. But you know what? It works just fine. And it's out there exposed to all the elements, and it still works fine. It's fantastic to charge at home and not go to the gas station. I am tracking how much I save by participating in GMP's EV program. Their home EV charger program gives you a discounted rate when you use. I can get more into that if anybody's curious, but I save about $25 to $30 a month, which adds up across the year. And that's on the power cost. So that's just on like the electrical cost through their program, less than the electrical cost GMP's regular rate. So that's not even including how much I'm saving, because it's so much cheaper to use electric right now, especially right now, than gas. So that has nothing to do with the comparison with gas pricing, which, Linda, I don't know if you have it on hand, but I think the last I saw it was like, it's as though you're paying like $1.50 for a gallon. That's kind of the equivalency. But so on top of that, you can get more of a discount participating in their program. You can use the heating and the cooling in the car without idling. So I've seen people taking Zoom calls from parking lots in the dead of summer, and they can run their AC while they're doing that if they have to. This doesn't work for me, sadly, but you can start your climate control remotely, which is really nice, because in the winter, you don't have to get into your icy, frozen, scraping car situation. And the weight of this has been the most surprising. The weight of the battery makes it drive like it's a luxury car. It feels like really surprising to me, and I don't even like cars, but now normal cars feel really jittery to me and unbalanced. Obviously, the cons, I think everybody is worried about charging infrastructure for long trips. That is a real concern. As sort of this hybrid method that we were talking about, where everybody's trying to make incremental improvements, I say that if you're a 2-car household, it can be great to have one EV and one gas or plug-in hybrid car, because then on those usually not all the time trips that you're taking that are kind of out of range, you still have a car you can use if you don't want to stop and charge. But sorry, my headphones just died. Can you guys hear me?
Yep.
Yes.
Side. So the infrastructure, but we're a household with one gas car and one EV. We try to use the EV as much as possible around town. And, so if I'm staying locally in the Upper Valley, and by locally, I mean like, out to Enfield from Thetford or, past Bradford. I don't mean like, Norwich to Thetford. Within our usual range, West Leb, the places we go, it's not a problem at all. Use the EV, charge it at night, totally never a problem, even in winter. It's when, I want to go to Boston or I want to go to the middle of Maine, that's an issue. And so I always encourage people to at least get one EV because the majority of your driving is locally. I hate the touch screens, software, terrible. People, I think, are dealing with that in regular cars too. And heavy batteries can cause the tires to wear faster. So that is something that will add a little cost, though you are saving on not having to do all the oil changes and all that other maintenance related to gas vehicles. You do need Wi-Fi if you want to participate in GMP's program, and it has to be at the charger, or it has to connect to the charger. So I had to actually buy like an outdoor satellite for my internet because this is quite far from my house, actually. So that was just something I had to do in order to get Wi-Fi connection out there. And I don't have cell service at my house. So some of the cool things that you can do don't work for me, which, some other people might also not have cell service at their house. So the remote heating and cooling works like 5 times maybe. And there are a ton of software updates and they only work when you're connected in cell range service. So those stack up and then I have to take care of them for hours, like, intermittently. So anybody else want to jump in on that? No, we've covered this a lot. All right, well, we're gonna take questions, but I just want to put up this slide. So if you wanted to write down any of our email addresses that we didn't put in the chat, you feel free to write them down now. We've also put this slide presentation on the Thetford Energy Committee's website, which is part of the Thetford government's website. I think if you Google it, it should come right up, but you can also email us. This email address goes to all 3 of us and Chris and everybody else on the committee. Or if you have specific questions about the things in our specific houses, you can reach out to us individually. And we've got a lot of information on our page. But yeah, I think we have a few more minutes if anybody has questions. Jason.
Yeah, one of the downsides of electric vehicles is that our legislators have decided that we're a cash cow for the state, and they added $80 surcharge to our registration starting last year. And to my horror, they apparently have legislation to charge even more in future years. The idea being that our vehicles are heavier than gas-powered cars. I have to say my Bolt and my Kia our Kona are both lighter than a gas-powered F-150. So I think that's a bogus argument. And the other thing is when I talk to legislators, they think they immediately, when I say I have an electric vehicle, they assume it's a high-end Tesla and that I spend $80,000 to $120,000 on it. I haven't paid over $24,000 for a used electric vehicle in so far, and I bought 3 of them now over the last 8 years.
1975.
Sorry, Michael, I think your mic is on. But yeah, Jason, I think to your point, my understanding, and Linda, correct me if I'm wrong, is that they're trying to make up for the difference that they're losing in gas tax revenue. So it's less about the wear on the roads from EV, but that since we're no longer buying gas, they don't get those taxes that they used to.
Well, that's a regressive and terrible tax on gas, but we shouldn't be using gas in the first place. And if they charged everybody in the state $1 extra for registration, it would make up the difference. And so it's a regressive tax for buying an electric vehicle, so it's a disincentive to buy an electric vehicle.
It does feel that way, but it is still cheaper to drive, especially these days. You feel good, I think, as you see gas prices exceeding
Yeah.
$4 a gallon.
You get happier and happier.
Yeah, I
But
feel
this,
good.
but this is the same legislature that we're very happy that Green Mountain Power and others were offering us rebates a few years ago, and now they're going the other direction.
I have a real quick question.
Go for it.
So does anyone have any tricks of the trade for getting snow off solar panels mounted on a roof in a two-story house? Because a lot of the winter, our panels are covered with snow and we just don't get electricity.
I can give you a partial answer that and I'd have to look at the thing. I have a telescoping, it's kind of like a roof rake, except at the end, it's not that metal kind of thing, but it's a telescoping thing with like a soft scraper that's like this big, and it works really well for my ground mounted panels. So the question for you would be, is there any access point where you could have some kind of roof rake length tool, and could you access your panels? And I think if you can't, then I think you just have to deal with it and know that here in the winter, you are in fact not losing all that much extra solar generation. You are losing some for sure. But in the wintertime, the generation from your panels would be much, much less. So I think if you can figure out how to actually reach them and pull some of the snow off, there are tools that you can use for that. But if you can't, I would say just don't fret it.
Okay.
You could also reach out to your installer and see if they have any tips. Because things are changing all the time. I mean, Klaus says that they never stick to his ground mounted panel, so something's changing. So I would say it's not a bad idea to just chat with your installer and see if they have any suggestions.
Okay, great.
Anybody else? Great. Well, thank you guys all so much for joining. And thank you so much to the Norwich Energy Committee for hosting us and recording this, since we had a failed attempt at doing that the first time we gave this presentation. And so hopefully other people who are interested in these technologies can view that and follow up with questions as they have them.
Yeah. And thank you, Erica, Klaus, and Pi. You guys are great, and you have excellent slides, and we're really happy that you were ready to do this presentation with us. Thank you. Thanks to
Thanks for hosting
everybody.
us. Awesome.
Thank
Good
you.
evening.
Thank you.
Thank you.
All right. Bye-bye.
Bye.
Thank you.